One other fact here before I move on. If integral f dr, the line integral over c, is independent of path, then line integral c f dr equals 0 for every closed path. Makes sense because if it's independent of path, then we can say it's conservative, and then our conservative vector field, we just have to do the potential function evaluate the terminal point minus the potential point at the initial point. Well, if it's a closed path, the initial point and the terminal point are the same. Those subtract out. Therefore, it would be 0. So, and this also works vice versa. So, all right. Now, all well and good, but what we need to look at here next then is if we need to know, is there a way to determine if it's conservative? Because if it's conservative, then the path doesn't matter. It's path independent, and so we can evaluate the line integral pretty easily. If it's not conservative, then that's a different matter. But if it is conservative, then we have a nice way of evaluating the line integral. So is there a way to determine if a vector field is conservative? We haven't looked at that yet. Well, it turns out yes. It turns out there's a theorem. Let F equal, we're going to call it Pi and Qj. For our component, P and Q are going to be our component parts. On an open and simply connected region D. Then if has continuous first order partial derivatives that's true, then F is conservative. Okay, so it turns out, and they go through the proof in the book. Like a time, I'll let you look at that, but it actually gets back to Clairaut's theorem, I think. But anyway, yeah, it turns out if the partial derivative of p with respect to y equals the partial derivative of q with respect to x, if those are equal, then it turns out the function, the vector field is it's called conservative, or is conservative. Which means, in other words, there's a potential function where the gradient of f equals the function, the vector field, big F. All right, so let's determine. A couple of these are conservative. A vector field xy equals not xy, x squared minus yx I plus y squared minus xy. Okay, and so we've got the p function is x squared minus yx and q is y squared minus yx. And so for this to be conservative, we need the partial of p with respect to y. See if that's equal to the partial of q with respect to x. The partial of p with respect to y, so that would be 0 and minus x, so it'll be minus x. The partial of q with respect to x, what we want to do there, well, that's 0, that would be minus y, not equal. And so that determines no need to look for potential function for it, where the partial, the gradient equals f. Okay? And its line integral would be a little more difficult to evaluate. All right? Here's the second one. The vector big F equals 2x e to the xy plus x squared y plus x cubed e to the xy plus 2y x to the 0. So this is our p, this is our q. And so what do we need? The partial of p with respect to y. Well, that's this part. First of all, that would be partial with respect to y. It would just be 2x. And we're just doing the e to the xy derivative. So e to the xy derivative would be e to the xy. And since we're doing it with respect to y, we need to do the derivative of the power. So that would just be x. Derivative of that with respect to y, well, we've got 2y, so we've got to do the product rule, x squared y times the derivative of e to the xy, e to the xy times derivative of power, which would be x, right? Plus, then flip it, e to the xy times the derivative of x squared y with respect to y squared. So if we clean that up, this is 2x squared e to the xy, and that's 1x squared, so we've got 3x squared e to the xy plus x squared y e to the xy. That's our partial p with respect to y. So look at the partial of q, but with respect to x. So q is that, so that would be we're doing with respect to x, so, we've got a product rule, so that would be 3x squared e to the xy, plus then reverse it, x cubed times the derivative of e to the xy, which would be e to the xy times y, with respect to x, plus then, 2y with respect to x, that's derivative 0. And so, look at that. 3x squared e to the xy. Oh, this one is x cubed. Sorry. So we got x squared times x there. So it's x cubed y e to the xy. So those two are equal. Exactly the same. So, that tells me that is conservative vector field. All right.